Okay, some announcements. So on the eCampus, you can see this is final exam extra points for essay writing. The topic is there. In the classroom, you're going to have to use handwriting to finish the work. But the question is open, okay? 250 to 350 words. Your handwriting can be recognized. It's 30 points, huge extra points for the final exam. I hope you do it. It's like insurance. Also, I corrected on the syllabi. The exam is early exam, December 13th, Friday afternoon, 12:30 to 3:30 in the lab room. Also, I want to spend a little bit of time talk about the grade. Okay, so 400 is total. This is A, and if you get this, this is A minus. Okay, so the cut line here is 340 with everything. Here is something I want to emphasize. We look at the final is the points. As long as you get 360 is A. You get 340 between that is A minus. I don't think people care about B or B minus or something. That's I will do some adjustment. You don't look at is the percentage of the eCampus. Because in the final exam time, the final week, sometimes they screw them. Especially if you're missing something. Ideally, I have to manually put 0. If I didn't put this, it's one count. You know what I'm saying? So you only going to become much attention is this final grade. As long as you score is above this, you're A minus, you're above that, with everything is A. Okay? Second, for the lab, this is a lecture. Okay, the lab total is 200. Above this, this is A. So same thing, you look at your grade. If you final score with every exam, unknown number 1, unknown number 2, dilution quiz, attendance points, and your extra points for lecture, for the attendance Amy's lab, and also your lab notebook record, as long as you above that is A. And especially the extra points, because I have to put a separate category, but it won't count with percentage. Okay? If somehow you are this is A minus. Okay, usually the lab, everybody is pretty good. Barely have 1 or 2 people not very good. Most of the people, very good. Okay, because we design a very nice grade system for you. So you want to look at this. Well, you this safe, that's safe. A minus not affect your GPA, but look you transcript a little bit ugly compared to people have A. So that's something I want to mention. The bottom line is that look at your total points, not the percentage under eCampus. Because eCampus sometimes will be screwed, especially as extra points I cannot put there. Okay, so that's why I want to explain this before we go to the lecture today. Okay, so we're going to have this lecture. Is an interesting topic. This one is talk about the poultry meat processing. Lots of you attended Corey's lecture, my students' lecture about the feeds. So here we're going to talk about is poultry meat. So the topic will be microbial safety of poultry meat processing. So first of all, we have this slide to show you. Let me see whether I can put this a little bit large. The boar production in the United States. The picture here, which is showing you what's the boar production in the United States. And unsurprisingly, majority of the poultry states is in the south. So you can see, let me find a way how to, wait a a second. It's just too small. How do we make it be large? Let me see. I don't know why it's still like that. Well, let's just be like this. Maybe here should be a switch. Go here. Maybe this helps you a little bit. We'll just do like this. So if you look at the map of the United States, the poultry state is relatively in the south. This tells us another information. I always tell all my students, if you in the future are interested about the poultry science study, then the southern states, land-grant university, you should go. It's a good choice. There are 6 universities in the United States in the southern parts have poultry science department, which is North Carolina State University. You see NC, huge amount of the boar production. In Georgia, University of Georgia. In Alabama, Auburn University. In Mississippi, Mississippi State University. In Arkansas, University of Arkansas, and Texas A&M. Those are the 6 states have poultry science department at their land-grant institution. The reason is it's a big industry there. And I often make a joke because it is hot. And the poultry's intestinal temperature is always 42 degrees Celsius. So the environment's fit for the poultry to survive and grow very well. But this tells you that. So let's look at here. I used to be work at Kentucky. Kentucky had a little bit, but they tried to get rid of the poultry production because of the waste. It's difficult to treat it. Virginia a little bit, Maryland a little bit, Pennsylvania had a huge one really in the central T area. Is that right? Pennsylvania, we always make a joke. We say, except Pittsburgh and Philadelphia, the whole center part we call it a T. It's like Alabama, and it's a big agricultural area. That we have a beef, cattle, pork production, and also poultry. So poultry in Pennsylvania is also important. Penn State also had an animal science and the poultry science department, they combined. So Ohio a little bit, obviously Ohio State University is good for study. But very surprisingly, you can see, at West Virginia, we have ranked 11th in the whole United States for the boar production. That's why we had our poultry farm, our poultry research going on here with Dr. Joe Motz. And I partially do some of the work with him to do the microbial safety part. And the majority of these boar producer is small producer, and they are in the Eastern Panhandle, in the border area with Virginia and Maryland. Let's say there's a Hardy County there, which is a big poultry county in the eastern part of the West Virginia. But if you look at here, Colorado, Wyoming, Utah, Kansas, Nebraska, they don't have much of the poultry production because those are big cattle states. Okay, California, obviously Central Valley is a big fresh produce production. So this is a map of the boar production in the United States. Again, southern parts of the states are big poultry states. So this one we talked about before briefly. It is different from E. coli 0157H7. There are 2 major pathogens is a concern for the Borococcuses, which is Salmonella and the Campylobacter. But they are not zero tolerance. Salmonella is allowed to have up to 7.5% positive. Campylobacter is up to even higher, 10.4%. Remember, this is the borer carcasses, and this is established by USDA FSIS in 2015. So we call it new performance standards, relatively new. It's about 10 years. But before that, we don't have this regulation. So this regulation comes about 10 years ago. So keep in mind, they allow you to have a certain level of the salmonella and the campylobacter. This is borer carcasses. And I mentioned in the lab, for frozen chicken products, let's say like nuggets, right now, salmonella is 0 tolerance. So it's different. These two pathogens we already talked a little bit. Salmonella, this is a gram-negative, large shape, facultative, and very important, it's a mesophile. They can grow up to 45 degrees Celsius, which means if you inoculate the salmonella in nutrient broth at 45 degrees Celsius incubator, it can still grow. Campylobacter, this is, we call it's a fastidious bacteria. It is very difficult to grow in the lab. It widely existing on the skin surfaces of the borer carcasses. So it is very ironic. And this pathogen, why it is fastidious? Because it's a microaerophilic bacteria. They require the survival is 2 to 7% of the oxygen. So in order to grow Campylobacter, we need a special media. Usually it's a modified chocolate agar. And add vitamin K, add some other ingredients. It's like an enriched media. Then we need to put in an environment which is containing 2 to 7% of the oxygen. So what we have to do is either using a microaerophilic jar or using a chamber. The jar usually costs like $400. The chamber could be up to $25,000. So that's very ironic. It's a major concern, but it is difficult to grow in the lab environments. So these are the two things we just briefly mentioned here. So we did some of the research. This is the research what we did before with my students. A very small borer producer. And you can see in this one is in Cheater, it is in the Deep Creek, which is a border area between West Virginia and Maryland. And we sampled 42 carcasses. And we using traditional enrichment methods, modified FDA bacteria analytical menu, and we find 29% is salmonella positive, and 40% is Campylobacter positive. The paper we published at the Poultry Science about like 8 years ago, their production is 212 borers every day. The bleeding 2 to 2.5 minutes, and the only treatment what they do is after they process, they dip in the lactic acid solution. And then we can compare the research did in University of Georgia. And you can see the above one is salmonella, the bottom one is Campylobacter. You see the Campylobacter is very high. The overall percentage is 40 somewhere, 40 to 100%. And Campylobacter, this is Campylobacter, salmonella somehow, you see, could be a very wide range, could be only 8%, but as I has 94%. So this tells you, a small borer producer in the West Virginia area, even in Georgia, at the poultry state, is difficult to control the level below to 7.5 and 10.4. And our test sample, even in a very small scale, isolated testing samples, The number is higher, much higher than that. So you don't think this standard is easy to achieve. It is difficult. Now, in order to achieve these requirements, the big industry in the United States have a standard broiler processing. You can see the flow chart is right there. And including like transport, live hand, immobilization, we call it bleed out, which is exquisition, then scourding processing, pickling, evisceration, then chilling, and between evisceration and chilling, there is another important step called inside-outside bird's wash. And finally, we have to do the aging, and then further process, and finally is packaging. Now, not saying that every step is important for the microbial safety, but some of the steps are very important. So we want to talk about some steps which is important for control the pathogen. Okay, the first thing is important, the scourding. Scourding is very early. People created their methods back in 1st century AD. So the scourding you can read, the partridge is scoured with its feathers, and while wet the feathers are taken off, the hair thinned. So the idea is easy. We're going to dip in the carcasses with feather into hot water. Then the feather could be softening and then easy to take it off. But there's some misunderstanding about that. And the temperature control is important. So the next slides will tell you. Okay, there are two different types of the scourding. Number one, we call it hard scourding. The temperature is very high. 59, 64 degrees Celsius, 30 to 75 seconds. The second method uses a little bit lower temperature. We call it a soft scourding. So 51 to 54 degrees Celsius, 90 to 120 seconds. But there are two misunderstandings. Number one, there are lots of the small producers. They are using warm scalding water. How warm it is? Around 42 to 45 degrees Celsius. Why they do it? Because it's easy to do the defeathering. Otherwise it's too hot. But what's the problem? I just said, Salmonella is a mesophile. If you go back to see the slides, what we talk at our exam 1, we talk about cyclotrophs, saprophiles, mesophiles, thermophiles. Mesophile can grow up to 45 degrees Celsius. So, if you are using 45 degrees Celsius to do the scalding, what will happen? You are cultivating bacteria. It sounds like a joke. Instead of your control, you're cultivating it. And it grows very fast. This is the first misunderstanding. The second misunderstanding, lots of people say, how about we use hot water? I use more than 70 degrees Celsius because they think if I use hot water, it can be killing bacteria. Is that right? That's what they think. But it is wrong. So why? This is talk about skin surface. Okay, skin surface of the broiler carcasses, there are lots of fatty acids. You know that. You boil the one chicken, you see the soup, and there is oil there. So what are they? This is lots of the time we talk about this. We talk about that. Triglycerides. Is there right? Stereospecific number 1, number 2, number 3. In this position, usually is unsaturated fatty acids. So what happens? If you are using very hot scalding temperature, you are doing lipidization happens is all these fatty acids will be extracted and then floated on the surface. When they do chilling, which is the last step, these will be completely floated on the chilling water and then become a huge organic matter. And the organic matter will neutralization or significantly decrease the antimicrobial chemicals, the antimicrobial capability. So I will show you that. That's a very simple misunderstanding. So do not use very hot water. Another thing is that some people think about, in the scalding processing, how about we add antimicrobials? Can we do that? No, because lots of the oxidants, they will generate off gas. Hydrogen peroxide, chlorine water, chlorine dioxide, they will make people sick and also create high organic load. The last thing is very important. The scalding water needs to be counter current. The flow of the scalding water has to be counter current, which means every time the birds come in, they are facing the clean water. This is very difficult to do, I can tell you. We went to see a lot of the small producers in West Virginia. They said they did it, but actually when you see it, it's not. Lots of times they're tumbling. Because the flow rate and the pressure is important to do the control. Another reason is that the people who designed that had an idea as a mind of the food engineering, but they do not have a concept of food microbial safety. So that's why when you see the countercurrent, you said it's very easy, but it's difficult to do. So the scalding, there are several points talk about microbial safety. Okay, next one is pickling. So pickling, what do you have? You have that Sika area, you have that AEM there. So you're handing there. What are we concerned? Feed withdrawal. Feeds withdrawal. We don't have to. We don't want the birds is eating too much before they do harvesting. What happened? The intestinal area will fill with all the feeds. And that is a resource for bacterial contamination. Especially later on, when you do the evisceration, which means you take out all the intestinal material out, it's very easy to break it. Second thing, we don't want the feed withdrawal is too long. If it's too long, what happens? The intestinal area is very soft, so it's very easy to break it. So the feed withdrawal, usually what we do is somehow 18 to 24 hours. That is important. The next step, evisceration. This is a picture what we took from the WVU farm. So evisceration, it is a major point for cross-contamination. Because we manually take all the intestinal area out of the boar carcasses. And if the equipment is not adjusted correctly, improper feed withdrawal, we just mentioned the weak intestinals, will have a huge cross-contamination. And you can see the pictures there. The bird was not off the feed for sufficient time. You see the fecal sample. You see the cross-contamination. Obviously, you can see it. So what we do? After evisceration, for the big industry, they handing the birds back in the processing line. We call online reprocessing. OLR. The online reprocessing will do a very important job called inside outside bird's wash, which means they are using antimicrobials. So you can see the picture there. The left side, the distance is good, the spray is very good. You need a good control of the distance, the volume of the water, and the pressure. On the right side, it's not very good. You look at that. And there is some example which doesn't even work. The nozzle doesn't even work. It doesn't have the spray any of the liquid. It's very important for lots of the parameters to be controlled. So for example, if you're using chlorine water, the allowable chlorine level is 40 to 50 parts per million. And we need to adjust the pH to 6.5. And we also need to make sure the pressure is important and have a good distribution, which is cover the surfaces. And the spraying time is usually about 20 or 30 seconds. I don't think any company will do more than 30 seconds. Now, next question is, what are the major antimicrobials they are using in the United States? This is done by Dr. Shelley McKee in 2015 with her graduate students. She used to be an associate professor at Poultry Science Department at Auburn University. Then she left Auburn University, joined the Chicken Council at Atlanta, Georgia. And her students and herself published an extension paper, which is doing the survey of the antimicrobials using for the online reprocessing process and the inside-outside bird's wash. So what is the number one antimicrobials they are using is perioxyacetic acids. Number two is chlorine. Then the weak acids, and the last one is acidified sodium chloride. And I'm going to talk about several of these, okay? It used to be chlorine, but later chlorine has become the number two. By the time the United States and Russia, they still do the business. If you want to sell the birds to Russia, they not allow you to have them washed by chlorine. So that's why the perioxyacetic acids comes out. So we want to talk about all these things one by one. So chlorine. I want to talk to this antimicrobials. It's very interesting. We can spend some time to dig about that. So first of all, chlorine is very cheap. During the COVID-19 time, I believe you heard about these things you buy all the time. That bottle, $3, $5. What is the major ingredients? Sodium hypochlorite. And the others are water. So you need to know, when you buy a bucket, it's not a pure chlorine. It's already diluted. What are the major components of the chlorine? Is this guy. It's hypochlorous acids. That is a major antimicrobial component. But what happened is, the chlorine, when they dissolve in the water, they will have a different species. The species is controlled by the pH. So what happened is, you see this red curve. When the pH is higher, the major component is OCl minus, that is chlorine ions. That is, when you buy a bucket of the chlorine, you dump in the water, you don't do anything, at that moment is hypochlorite is dominant. It doesn't have a very strong antimicrobial efficacy. So what we have to do? You have to decrease the pH. Because we want hypochlorous acids, HOCl, is dominant. So you have to decrease the pH somehow between 6 and 7. There are two methods we can do. One method did by the poultry industry is pumping carbon dioxide. Another method by the fresh produce industry, they add citric acids to lower down the pH to 6.8. Because when the pH is 6.8, the dominant is hypochloric acids. So another thing what will happen is, chlorine is very easy to be integrated, to be affected by organic matter. So I give you a very example. You have a bucket, you have a dust, you have a soil. Then you dump in chlorine solution. The chlorine concentration will be decreased from 50 parts per million to 0.5 parts per million in 30 seconds. So what do people do? They repeatedly add chlorine. They repeatedly add, what happens? The pH will be decreased. Then what will happen? Off gas will be generated. How are you going to feel about off gas? You're crying. It's not because you're sad, because it's going to be irrigation, or we say it's intimate of your eyebrows. You can say that. So that's off gas will generate at a low pH. So that's why when we do the chlorine, there are two things are important. Number one is a pH control. It has to be at the neutral pH, 6 to 7. The second is when you do everything to put the chlorine there, the surface has to be cleaned first, which means there's no organic matter. So some of the research what we did before, this is what I did a long time ago. You see the pure chlorine solution, curing E. coli O157H7, very effective. You use 0.5, can kill E. coli O157H7, these 4 strings, in 10 seconds. But what happened is, if you are in a prepared chlorine solution, then you are keep adding the fresh produced juice, which is add as organic matter. Then you see the free chlorine concentration will decrease. Now here we have a total chlorine. The total chlorine, which means everything here, that's the total chlorine. The free chlorine is only hypochlorous acids. So this is referred as free available chlorine. Okay, the pH control is important. So when you have a big ratio of the fresh produce and the water, the chlorine concentration is decreased. A total chlorine concentration is also decreased. But the only thing haven't not changed too much is the operation reduction potential. That is tells us you cannot rely on operation reduction potential to determine whether the antimicrobials is working or the chlorine solution is still working. Okay, so that's something we want to talk about. Something else. This is our lab. We did some research. We tested the antimicrobials for 30 seconds dip with 2 minutes drain. We're using peroxyacetic acids, lactic acid, citric acid blender. We call it a chick side. The reason is, originally people are using lactic acid. But lactic acid will cause the discoloration and the yellow color of the chicken wings. So they will generate another buffering solution, which is called the lactic acid citric acid blender, and the commercial name called chickside. And it's very interesting. They're using the fresh produce area. They change the name, become vegicide, then they can use the fresh produce processing. The chlorine solution. And for the peroxyacetic acids, they also can combine with hydrogen peroxide. So the commercial name comes out called sandidate. It's right here, the sandidate. And this is the pH level. It's very low, some of them. And the temperature. And also the concentration. We have to follow the FSIS, the recommended concentration. So here's some things we want to introduce to you. We talked about the chlorine already. So what is peroxyacetic acids? Acronym we can say PAA. Peroxyacetic acids is acetic acid. This is acetic acid with hydrogen peroxide, and then we'll create CH3, I'll just write down here, sorry. This is too far away. So, acetic acids with hydrogen peroxide, they will generate a material Just like that. That's important. This is PA. They could do oxidizing. What are the two locations they could do oxidizing? Oxidizing the lipids. Then where are they? Fluid mosaic model. What else? Lipopolysaccharides. Salmonella is gram-negative bacteria. There's a lipopolysaccharides outside of the cell wall system. So that's the oxidizing process for PAA. The PAA is also be approved to be using for certified organic poultry processing. So this is what we did. You can see we are comparing Salmonella and the Enterococcus faecilis. Enterococcus faecilis, we mentioned very briefly, it is a surrogate bacteria for Salmonella. And we're using different media. XLT for hardychrome, which is selective media, bioesculin agar. Esculin become esculating, we mentioned, show black colony. And you can see the best effective antimicrobials is peroxystatic acids. And you also can see the cold stressed cells showing a little bit more susceptible to the treatments. Because once you cold stress, the fatty acids of the cell wall and cell membrane system will be rearranged. So make the cells is more susceptible to the antimicrobial treatments. So you can see here, the cold stress compared to the unstressed cell, cold stress is much more susceptible. Okay, we have lactic acid, citric acid. We want to talk about those weak acids, how they work. You can see obviously, those weak acids compared to peroxystatic acids, it's not very strong. It is about 0.4 to 0.6 log weak or less reduction. So what are those things? This we want to talk a little bit about chemistry and about antimicrobials. So when we talk about lactic acid, citric acid, those are weak acid. Weak acid, COOH. Is that right? Kind of like this. So, weak acids dissolve into water, where this guy comes out, and this guy comes out. They are at certain pH level. The concentration of the combination, we call it undissociated, is equal the dissociated format. The concentration is the same. Equals dissociated chemicals. At that pH, we call pKa value. And for these antimicrobials you have to use is close to the pKa value. So pKa value are somehow 4 to 4.5 pH. However, on the poultry carcasses, if you measure in the pH, it's about like 5.5. So these antimicrobials are slightly outside of the optimal pKa value range. Now, how they kill the bacteria? When they go into the bacteria, the only thing they can come in is this undissociated. So this undissociated one coming, let's say this is a bacterial cell. They come in. Then they will dissociate it. Become like that. At the same time, what they do? They activate ATP, become ADP and phosphate. And this needs ATPase. So bacteria has to use ATP. Once bacteria use ATP, the more they use, what tells us they're going to exhaust it. Because you're not going to generate ATP, you're only going to use. So finally, you will be exhausted. So that's how they kill the bacteria. But you know that for bacteria, they always can survive. They kind of find a bypass to create more ATP. So that's why the weak acids, usually the curing the bacteria, is somehow 1 to 1.5 log 10 CFU per gram sometimes, the reduction level. And lots of the time they're static, which means it is not curing bacteria, it is only inhibits the bacterial growth. Okay? So that's an important thing for these weak acids. Remember, we talk about spray, inside, outside birds wash. The big industry can do that. Small industry, they're not going to do. So what we do, we help them to using a new tool, not really new, called electrostatic sprayer. This one I have in the lab, which is like a bag, and I have a nozzle, have a spray system. We bought it from the electrostatic spray system BP2, a company in Georgia. It's expensive, $2,500. And what's the advantage for this spraying system compared to the traditional spray? And what happened is, they're a little bit nanotechnology, so the particle sprayed out is negatively charged. And the subject, usually it's positive charged. So negative and positive, they could be attracted with each other, so they have a very good coverage. So you can see, so using an apple or a ball as example, with the electrostatic, the surface is covered very well. And without that, only half of them are covered. And we did this example using eggs. So this is one of my graduate students did a couple of years ago, using the eggs inoculated with Campylobacter, do the electrostatic spray and the conventional garden spray to see the reduction of Campylobacter on the eggs. And we can see across the board, using PAA, lactic acid, citric acid, blender, chlorine, and cyanidate, which is a mixture of PAA and hydrogen peroxide, we see universally the electrostatic spray have about 1 to 2 log reduction, extra reduction compared to using conventional spray, because the surface is more coverage. But there's one thing, and we can say the good thing, is the flow rate. The electrostatic spray, the flow rate is less than 1 ml per second. Conventional spray is more than 7.2 ml per second. And this is important because in some of the places, the water is expensive. And we even, working with our agroeconomic person to do the analysis, we find that in using electrostatic spray, if you have a huge amount of the eggs, the chicken wings produced, it will be very beneficial. Although, if you buy this equipment, it costs you $2,500. Okay, last step, chilling. Okay, what are the chilling? After you do the online reprocessing, you put the birds in a prepared chilling tank with ice water. In this time, we also going to using antimicrobials. What are the antimicrobials they're using? The industry survey by Dr. Shelley McKee in 2015 find a very similar to inside-outside birds wash. Number 1 is peroxyanic acids. Number 2 is chlorine, then weak acid and acidified sodium chloride. And the chilling process, usually it is very effective to killing bacteria because of the time, the exposed time. The chilling processing somehow is more than 45 minutes to 1 hour, could be up to 24 hours. It depends different processor. Because you have amount of the antimicrobials there. and you have enough exposed time for the pathogen to the antimicrobials, so it is the most effective way to control foodborne pathogen. And you can see chilling can cut salmonella incidence by 50 to 70% if operating properly, because it has enough contact time. Now, another thing I also want to mention, not only for the chilling itself, we talk about the scalding water, we talk about inside outside the bird's wash, we talk about the feed withdrawal, we talk about chilling. Those multiple steps work together could be very effective to killing the bacteria, and we call it a multiple hurdle concept. But there is something I want to mention. I talked about already. This is what happens, the picture on the right side. If you are using very high scalding temperature, if your scalding temperature is more than 70 degrees Celsius, what happened? The fat build up in the chilling tank. Because you're using too high scalding temperature, the skin surface fatty acids is extracted. We call it a lipidization. And then in the chilling tank, the temperature all of a sudden is go down, they all floated, extracted. They treat as an organic matter. The organic matter will be severely affect some of the antimicrobials, such as chlorine. And there is a research has been showing in the chilling tank, if you have a fat build up like that, then the birds coming in the chilling tank is 40% salmonella positive, and when they comes out, is 53% positive. The positive rate not only did not increase, not only did not decrease, it is increased about 13%. So this is what we have to avoid. So here are some good examples. Very good chilling tank water. Look at the water here, very clean. That's what a good example. But unfortunately, these two pictures are not took from United States. I got the courtesy from Dr. Scott Russell. He passed away 7 years ago because of the liver cancer. He's an extension specialist and a professor at the University of Georgia Poultry Science Department. I talked to him a couple of times in the meeting. He said this picture is coming from a sabdo, and this is coming from Chile. And very ironic. It's not, you cannot get even a very good picture from the United States. So we can only get some of the bad examples. Okay, what are the people going to do in Europe? They do air chilling. So if you buy a bag of the poultry, especially organic processed poultry from the Whole Foods, they sometimes says no antimicrobials, no water added, no moisture addition, and we're using air chilling. Air chilling, you just hang around it, using the air, so cold air to chill it. We don't use antimicrobials. So we are very glad to say that the birds in the United States is relatively very safe. So this is the survey results. The percentage of the salmonella positive in United States, European Union, and Australia. United States is 5% positive for salmonella, around 10% for Campylobacter. This is the reason, the resource where we set up the standards of 7.5 and 10.4. EU, European Union, relatively high, 16% for Salmonella, 74% for Campylobacter. But we have to say that the European Union, the results is very wide range. In Western Europe, in Germany, Netherlands, it could be only 1%, 2%, but in Poland, in Slovakia, that could be more than 70%. So you average it, it's giving you a high number. Australia have a 35% of the positive for Salmonella and more than 80% for Campylobacter. One thing I want to mention, why the United States, the Salmonella and the Campylobacter, the positive rate is relatively low, because we have in-house keeping work. We're using antimicrobials in a couple of locations. European Union don't do that. They do air chilling, and they're using vaccine. But the vaccination, relatively safe, maybe works for Salmonella, but not very good for Campylobacter. So that's a reason, one of the reasons European Union has a relatively higher number. Okay, what we do in West Virginia, we don't have a big industry, but we have another one, which is called the Mobile Poultry Processing Units. This is the Department of Agriculture in Charleston and the Farmers Market Association work together, try to let the people do that. So there is two types of the mobile poultry processing units. One is the open air, another one is the enclosed MPPU. The difference is that, number one, obviously, is the price. The open air MPPU, $30,000. Enclosed MPPU, $90,000. And the amount of the borers processed per hour is different, slightly different. Open air can process 90 birds per hour. Enclosed can process 120 birds per hour, up to 200 birds. The amount of the birds processing in the open air MPPU, 50 to 300 birds. Enclosed MPPU is relatively high, but the waste control is sometimes easy to do. Mobile poultry processing, this is what we did in our poultry farm 2 years ago. You hand in there, what we do scattering. Then we do defeathering, manual exquisition, and chilling. And we test the chilling temperature. We have to make sure it's below 35 degrees Fahrenheit. Chilling 24 hours. We had a new paper published at the Poultry Science. We tested every steps. After scattering evisceration, we use water chill and use 5 parts per million chlorine water. That's what we did in the West Virginia. The local producers are using Arabic coliforms. This is what we tested in the same as we did in the lab. No big difference. Generic E. coli. We do see if you're using chlorine water, 5 parts per million, it's about 0.6 log reduction after chilling. So that tells you chilling definitely helps you. How about Campylobacter and the Salmonella? And I tell you one thing, it's huge. At the beginning, after scattering, 5%, 5 of them, 5 among 32 positive. Then that's increased after evisceration to 11 among 32. Because the evisceration, obviously, the intestinal area you touched and then it goes on the surface. But after chilling, we only find 1 of them are positive. Campylobacter, surprisingly, we didn't see much of the positive in our farm. So what is the difference? WVU poultry farm is not a commercial poultry farm. The MPPU processing is only for research and less frequently used because we do a good job of sanitizing and cleaning. We call it a standard operation procedure. So we control the pathogen really well. But when we, at the beginning, we talk about all those commercial, they are more frequently used and less, they do a very good job of cleaning and sanitizing. So, we want to work with them. This is what I worked with my Dr. Joe Mortz, my students Tim Boats, and Lisa Jones, which is a coordinator of extension, WVU Small Farm Conference. We write a manual, which is an extension manual for the mobile poultry processing for the microbial safety manual. We published it, we gave the guidance of the small producers, what we should do, and what we should to help them to improve the microbial safety. Okay, so that's the end. So gives you an overview picture. What's a poultry microbial safety, the application standard points in the United States. Some key points for the exams I want to say. Scattering temperature control is important. We have a review question too. Antimicrobials, you at least need to know a couple of antimicrobials, the name they're using during the inside-outside the bird's wash and the chilling process. Okay, what's the acronym of the IOBW? That's called the inside-outside the bird's wash. What is the acronym of, we call it OROLR. That's called online reprocessing process. Okay, we have a question for you to do the review. Okay, so that's all we have. Thursday we don't have a lecture. because I wanted folks for the final exam of the lab. Next week, Tuesday, we're going to talk about the immunization. Thursday, we talk briefly about virus. We do the final review. If you're feeling very comfortable, you can take the early exam next week, Friday. The review question we'll post it online next week, Monday. So you can study to go ahead to study it first. Okay?